Next up, we have Scott Hammerschmith with Orenco Systems, and he's going to go through some control panel controls and troubleshooting and maybe some pitfalls and things we see in the field for you guys to look out for. Scott joined Orenco Systems in 2005 and currently serves as their sales and application engineer for customers in Oregon, Washington, Idaho, Alaska, Montana, and North Dakota. His responsibilities include design support for commercial Advantex systems and field training with installers and operators. In fact, Scott's led the development of the Oregon service provider network and has worked with service providers across the U.S. Scott earned his associate's degree in applied science from Umpqua Community College and has worked as a contractor doing site work, excavations, wastewater system installations, concrete finishing, prior to working for Orenco. Before focusing on commercial systems, Scott was the regional manager for the Pacific Northwest region for the residential product segment and spent time as the field representative in Oregon. When he's not working, Scott enjoys spending time with his wife and 2 children. Scott?
Thanks, Justin. Thanks for reading my bio in its entirety.
Yeah, not ready to.
Yeah, I usually just be like, hey, I've been with Orenco for 9 years, but yes, I'm Scott, and I'm from Orenco Systems. Of course, came in from Sutherland, Oregon, and for this portion or today, we're going to talk about the somewhat elusive control panel troubleshooting. As we were talking about earlier, there's some unique challenges that always seem to come into play when we're dealing with electronics, and especially since, as many of you know, we're dealing with an electronics package that's not, how I say, pre-wired. It's not like your vacuum cleaner where you just get to plug it into the wall and you flip a switch and it turns on. You're dealing with, having to wire in a series of switches out in a remote area and then make sure that they're appropriately wired so that they operate together. Today we're going to talk about just standard control panels. I'm not going to cover the custom control panels class just because we've only got an hour today, and quite frankly I could spend probably 6 hours sort of ground up teaching you how to install, wire, and effectively troubleshoot standard control panels. So we're going to just concentrate on that in this next hour. The two I want to talk about briefly is that you have our standard series, and some of you guys probably recognize the timer in here, the Omron timer. If some of you guys are old enough, you may remember the orange Searlick timers that we've discontinued. But with our S-Series panel, these are an electromechanical panel, which means that there's no really digital aspect to it at all. It operates off of analog relays. Even the timer in here itself is not digital in nature. It's got a coil set that's in it based off of whatever time set to turn pumps or relays on and off. So this is, oddly enough, this is probably still one of our more popular panels. We use them all the time on step systems where we don't need the digital accuracy or ease of the MVP, but we'll talk about why we've gone to that panel as well. And of course, you can use them for 2-pump sand filters or duplex alternating, lift stations, those sorts of applications. The MVP panel, of course, is we have our trademark Siemens logo unit right here. And what that is it's a small digital PLC, which allows us to basically eliminate all the analog relays, have a centralized place to control the functions in its entirety. And what we'll talk about when we get into we'll talk about it a little bit, but what you'll notice is when we get into the hands-on portion of the training is this is incredibly useful for troubleshooting. Not just for the guy standing in front of it, but if you're calling in for technical support, I'll tell you what, for the standard panel series, if you're standing in front of one of these and you call my desk, I'm very pleased. If you are calling in and you have the standard electromechanical, one of the first questions I'm going to ask you is, hey, you have your voltmeter handy? Because with this particular panel, I have no way of knowing inputs, voltage, those sorts of things other than actual, manually running the pump type of stuff. Then of course, a few guys asked about this. It's our Varicon control panel. We do have a S-series and DAX series in this, as well as, of course, it's, the most popular application is on our Advantex treatment systems. And the Varicon control panel, basically we're taking the control module and we're putting it here. So it's not a PLC base, it actually has a motherboard that has a processor on it. We use a flash type of memory in it to where when you make adjustments, they do save if you back them up to the firmware. Really, this is a very, very specialized panel in the fact that, again, we use it on treatment systems, some step systems or other type of collection systems where we need the web-based monitoring. This panel communicates over an analog phone line or over an Ethernet signal. And the intent behind that is if there are any problems, it will communicate via email to an operator, and or every month it will call in and give an update. Depending on what type of system you have, it can let you know flows, it can let you know if there's been any problems, it lets you know if there's been a lot of high usage, etc. And I've already covered that. I'm going to kind of go through this quick because I know we're going to do the fun stuff here in a minute, so that'll take some time. Here's our Advantex treatment system. You have the AXA and the AXB style. Really the only difference is that this supports the single recirc pump, the AXA, and then the AXB has the additional pump in case you need to pump up to your drain field. Just, not uncommon at all. Actually, that's, well, at least in Oregon, I know that's like 80% of our installations have a second pump. Out here, you guys, I don't know if you're running that quite as much, so you have a little bit deeper drain fields, but I know it's still done regularly. So just some features, this is kind of for your information. What you'll notice is that the motor contactor in here, and you can call this a motor contactor, you can call it a pump start relay. I would stay away from calling it a soft start relay because that's not what it is. But these particular relays are rated at over 2.5 million cycles for a lifetime, which is, and that's a full load amps, which is a big deal because if any of you guys ever operate these things and keep track of pump cycles, you know that over 5-6 years, the days start adding up, right? You can get into thousands and tens of thousands of pump cycles. So it's important that we have a relay that takes that. The separate circuits, not necessarily on the commercial end, but on the residential end or the standard side, we do isolate the pump and controls. And the reason we do that is if you have an alarm because of a pump failure, the circuits are separate. Because on pump failures, sometimes what we've seen is that if you have a short in the wiring, if you have a motor that's gone bad, the motor will draw really high amps. And little known fact, the circuit breakers in our control panels are a Class C breaker, which means that they're a slow blow or slow trip. So they're pretty robust and they can take the hit from motor starts. Unfortunately, most of the circuit breakers in the house and the panel and sub panel in the home are not that classification. And so that breaker in the home tends to be the one that goes first. And if you've got your alarm and pump hooked up to that breaker and it trips, will your alarm go off? No, it will not. And so what you'll notice in a lot of our documentation is that we recommend actually running separate circuits out. That way, if you do have a pump failure or pump problem, the alarm circuit is at least isolated from that breaker. The panels are touch safe. One of the jokes I always like to say, of course these panels are hot and live, they're plugged in right now, but I was at a training in Bend, and I was kind of joking around, I was telling the guys how touch safe the panels were. Of course we had an energized panel, and I stuck my hand, I said, see look, I can take my hand and do this, and then I went like that, and all the guys, like some of the guys kind of jumped out of their chair. And I was like, no guys, I'm kidding. It's touch safe, but it's kind of like the airbags in your car. Don't dip your hand in a bucket of water and test it, just like you don't run your car into a post to see if the airbags work. Okay, they're touch safe because it's a rating. Some options, of course, we've got lots of options. The nice thing about the elapsed time meters and the counters is when you move into an MVP style of panel, it's built into the logic, it's already included. You don't have to order it as an adder. Then of course we've got heaters, timers, We can do current sensors, run lights, all sorts of stuff. Just don't go hog wild with this stuff. Think of it from a practical standpoint. If I've got a S1 panel on the side of a house, more than likely, I don't need a power light, pump run light, a test switch, or a remote alarm feature, although they actually have outputs for the remote alarms. Just don't go crazy. Keep it as simple as possible, but if you run into a situation where you need that stuff, the options are available. I talked a little bit about some of the features of the standards and of course the stuff we can do with it, but another thing with the digital type of PLC where we go into the MVP panel is that you can adjust your timer very accurately. I kind of liken it to the standard panels have that Omron timer with the dials in it. And it's kind of like if you've ever set the temperature on your stove and you've got the dial and it's got like 350 and 450 and you need to set the stove to like 308 or 390 degrees. And so you like guess, I think it's in here somewhere is about 390. The Omron timer is kind of like that. You get sort of close. Close enough to bake your cookies type of deal, right? But I wouldn't do my prime rib that way, type of close. So with the MVP, we're within seconds on our dose rates, which is handy, and a lot of designers like that feature. Plus it's easy to program because you're not turning backdrop variables and doing all this stuff. If it says it's 3 minutes, it's 3 minutes. It's pretty simple. The other thing is the high-level alarm delay, which is handy in applications where you're sharing an override timer and high-level alarm. I've used this feature actually probably more than I should. It's nice, and I'll show you guys when we do the demonstration, but basically I can wait for like 30 minutes for the high water alarm to go off because maybe I've got an alternate cycle that I want it to try to catch up with. And so instead of just instantly alarming and alerting the homeowner, hey, there's a problem, it gives the panel an opportunity to catch up. That happens. Yeah?
Well, one of the things that I was taught before was just bringing that alarm up just a little bit, and that was basically the same thing as what you're saying.
If you have the override timer and the high water alarm as separate floats, but if they're shared, so you have like a 3-float system, then you can use this delay to help eliminate some of those problems. It's just as a suggestion. Like I said, it gives the panel an opportunity to catch back up, so it's not just instantly an alarm. And somebody asked me, they said, well, doesn't that mean that there's, you got sewage backing up into the house? Don't you want it to? No, not necessarily. Usually what it means is that somebody's using a little bit more water than normal. And most regulations call for that high water alarm to be below that invert anyway. You have to have so much storage above your alarm float anyway. So the 30 minutes is almost irrelevant. The other thing, and this is fun facts, and I'll demonstrate this here. If you have a low water alarm with an MVP panel, just an MVP panel, right? So we're not going to talk about the standard S1s. It will actually blink or flash, and we'll demonstrate that so you see exactly what that looks like, which is nice if you're rolling up on a job site. So homeowners called and they said, hey, I've got an alarm, and you're trying to decipher exactly what's going on. You see the light flashing, guess what? Low water alarm. If the light isn't flashing and it's solid, it's a high water alarm. So it's kind of tricky that way. The other thing that we rarely do, but sometimes, is we have the Eeprom card. We can actually reprogram the MVP panels. If you have some sort of surge event, is usually the only thing that I've seen that actually corrupts the programs. But if you ever have any problems or need some changes down the road, that's usually more in custom land. We can actually provide reprogramming chips so that you can do that in the field. You don't even have to have this guy come out and do it. You can do it yourself, so that's cool. The Varicon panel, I'm not going to talk about this a lot, basically operates the same as the MVP panel, aside from the fact that it's going to log data. And so we're going to keep a lot of keep track of a lot more activity, which is handy for troubleshooting down the road, especially when you show up to a site and you're looking for some after the fact stuff, like, well, how many times did it go into, you know, low water alarm today, or how many override cycles have I gone through? It's good for that kind of data tracking, and of course, as I mentioned earlier, it communicates over the web via phone line or an Ethernet connection. Real quick, I'm just going to talk about floats, and you guys are talking about the little differential on these guys. There's two basic types of floats when it comes to whether or not you're going to operate a motor off of them or not. It's you can or you can't, right? There's no like real in between. This is a signal rated float. If you try to put pump power through it, they tend not to last very long, and they tend to fail in a bad way, which is stuck on. At least that's been my experience. These are available in a motor rated float, which typically has a drawdown, which the drawdown, of course, is the distance between off and on, or on and off, however your circuit's set up. The larger drawdowns, of course, for the pumps usually have a contact in them, and you're looking at like a 3.5, 4-inch drawdown. Of course, various models give you various drawdowns. So those are signal rated, normally open versus normally closed. Kind of the last shining silver bullet for the MVP panel is this guy takes all A floats, so it's really simple. You go and you buy an A float, and you don't have to worry about, is it normally open, is it normally closed, do I have to have a differential, do I have to have this or that? You just pick up 3 A floats or 4 A floats, and you go do whatever you need to do. With the electromechanical panels, you need to be kind of careful, because the redundant off features on them, as some of you are already aware, take a normally closed float, which means is that when it's hanging, it actually has a closed circuit. Hanging being its normal position. I don't know why, I don't know who thought that up, but somebody said it's when it hangs, that's normal. So the RO float, normally closed, and if you mix that up, they don't work very well, do they? Some of you are smiling, that's good, you know how well they don't work. Okay, so just be careful with that. And of course, this is Darren, handsome Darren. Installation, and we're going to get into this. And you'll notice that I left something in all of my demo panels, and I know it's crazy, but we tend to ship every single panel, believe it or not, we send out from Orenco with this. You know what this is? It's an installation guide. I know it seems pretty wild and crazy that we provide installation guide. I have been to hundreds, I don't want to say thousands of sites, I don't think I'm there yet, I'm probably close. And I'll bet you maybe, well, let's say 5%, I'm going to be gracious today, 5% of the time I actually find this documentation on a job site. Usually it's the first thing, once the panel's opened, they pull the paper packing out, and this is just like that. It's a different color, but it just goes into the, yeah, it's the electrician's fault, there we go. But anyway, so in case you're wondering, the installation manuals do exist. They've got all sorts of fun information in them, including wiring diagrams, float arrangement diagrams, and of course we'll get into that here in a second. So read the diagrams, of course. Be sure that your floats are installed right. That's not just on the tree right, you know, clipped at the right elevation. Be sure that they're not in the way of each other, and also into the cord grips and the splice boxes and wired appropriately. And of course, be sure that your splice box is installed correctly. So if you guys come up front, I've got 3 panels set up here. And so if you just want to come up, we're going to go through some of the don't be shy, come on. We're going to go through how these guys operate, how they wire, how they program, and some troubleshooting techniques, which is, I'll go over to my whiteboard here in just a minute.
Look, he does the same thing I do.
Yeah, yeah, I was going to say that's first. So after you've seen this, which is your panel installation instructions, okay, you'll notice that one of the things I've done, I've seen on many a site, is I've removed the spade from the high water alarm. Part of it is that I think that they're training next door, And so I don't want to disturb them too much. As you guys know, it's an ear-piercing sound. But I've done that, like you guys said, just so that it's not obnoxious. I'm obnoxious enough, we don't need the high water alarm. The other thing that you'll see is there's a purple wire, and if you guys notice, it's jumped between 1 and in this particular panel should be 5, okay? And what that wire is doing is that we are powering the number 1 input. And we're powering the number 1 input because if number 1 isn't receiving a signal, does anybody know what happens?
It shuts off. Or-
Does it shut it off?
No, it just won't allow it to work, because it doesn't have, isn't that the bottom float that has to be in that upright position?
That is correct. It's the redundant off float. What else happens besides shutting it off?
Oh,
The alarm, of course. So to keep it out of alarm, right now I've got a jumper wire. We'll actually remove that here in a minute. So go ahead and let's power up the panels. And so we don't need to turn the pump breaker on, but we're just going to turn on the control breaker right here. You guys go ahead. They should all be plugged in. That one, there you go. Okay. And so now some of you guys have a screen. It might say float sets or status, or do you guys have the float status?
Yeah.
Float status screen. Okay, so this is a handy screen because remember how we talked about the voltmeter, right? You don't need a voltmeter at this point to see if your floats are sending a signal back. So right now, they should say that number 1 is up, and number 2 is down, 3 is down, and 4 is down, right?
Yeah.
Well, the sweet thing about that is that directly correlates with the terminal numbers. So terminal 1, where that jumper wire is, you guys see that? Okay. Terminal 1 has a signal. So what's the float saying? It's up, right? Okay. Now if you grab the float on the table and lift it up, you should see a change, right?
Yep. Up.
So now I know that my timer float or float number that's wired into terminal 2 is up, right? And go ahead and tilt it. There you go. Okay? And again, if I'm trying to verify that my floats, which can be somewhat problematic out in the field if they get hung up or full of water or swelled cord or all these things, it's a quick way, we're not using any voltmeters today, to be sure that the float's sending a signal back. And you can test it the other way too. If you guys set them back on the table, right? Floats back down. Quick and easy. There's another place to check this. And so on the logo units, you can go ahead and press the down arrow key. So you guys can go ahead and do that. And just press the down arrow key until you see a flashing date and time.
Boom.
And you'll see a bunch of different information on those screens.
Time?
Is it not flashing? Is it just the date and time?
Yes.
There we go, okay? So I call this, guys, what do you guys do to it? So I call this screen, this is sort of the center screen. The irony is that if the date and time is wrong, it makes no difference. Unless you have a very custom panel. The panel does not care what day it is. It does not care what time it is. It's actually a program feature if you're going to wire up for like an irrigation system, right? Then you put the date and time in and tell it to run on, Monday, Wednesday, and Friday or something. But for what we're doing, it doesn't matter. But it's a great place because if you can get to the date and time, that is the center of all of the programming. That's the spot to be. Because from the date and time, I should be able to arrow right just once. So press the arrow right key just once. And you will notice that it is an I: screen in the upper left-hand corner. I: stands for input, colon's the colon, right? Okay. But the I is for input. And you'll notice that the 1 is what we call backlit or highlighted. And the 1 is highlighted because no, that is correct. We're jumped into terminal 1, right? So go ahead and lift up that float again. And you'll notice that what happens? 2 is backlit. It's just like the float screen, only now it's direct inputs. Okay, it's the same basic screen. So you guys go ahead and put those floats down.
Oh.
That screen's a little harder to read. The older, and guys, the reason I'm showing you this one is because this is the new kind of latest, greatest version. But if you're ever working on an older panel, that float screen isn't there, right? And so you get to the flashing date and time, and then arrow right. There's your input screen. Same deal. So now we can arrow right again, and we've got a Q screen or an O screen. And sometimes if you're on the phone with one of us, this is an output screen, and we'll test the logo telling outputs to operate. And you might say, well, Scott, this is great, but what is it all, how do I translate it without being on the phone with an Orenco rep, right? If you guys look over here into the panel door, you'll see that there's a reference chart. And the reference chart is just that. It's going to tell you what every input and output translates into. So you'll notice that under input number 1, it says RO and low level alarm. Input 2 is our timer on and off. Input 3 is our override. And of course, input 4 is the high water alarm. And that's a sticker in the panel. That's not even documentation. So the electrician, it's really, really hard for them to screw this part up because unless they actually marker over it, which I've seen, it's a handy spot for you to reference what's going on before you even have to call Orenco. Okay, so we've covered inputs and outputs. And now if we want to just arrow, you can arrow left or right, but we're going to come back to that date. You can go left or right because it moves in a circle. Because once you've gotten down to that date, you can just keep going right or left, and eventually you'll run back into the date. Okay? So now we're back at the date again, which is the center. So the next thing we can do is press escape. So go ahead and press escape. And you should see stop, set parameters, I think it's set, and program name. Now, never, ever, 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 ever use the stop function because it's not stop alarm, it's not stop working for now, it's stop working forever. So if you press the stop thing, it'll prompt you and it'll say, are you sure you want to end the program? And if you hit OK, are you sure you want to do this? Okay, and after I think it's the 3rd or 5th try of us begging you not to eliminate the program, it'll actually delete the entire program from the PLC. So unless somebody that is an authorized Orenco representative is telling you to do it, don't ever do it. It does not stop the alarm. It'll stop the alarm, it'll stop everything for a while. So you're just going to arrow down to set parameters. And then you're going to see that on the side there's a little kind of little arrow. It looks like I think it's a less than sign or greater than sign. And then hit OK. And the first thing should be HLA delay, right? HLA DLY. This is that high water alarm delay I was just talking about. And you'll notice that the factory default is set to, what is that? Is that 5 minutes?
5 in.
Okay. The first we'll call is minutes, hours, or seconds. You can actually change it. In fact, we can do that right now. If you press the OK key, so go ahead and do that, you'll notice that it puts a box around that time all of a sudden, right? Arrow all the way over to that M. You guys there?
Yeah.
Okay. Now press up or down, whichever one, but it has to be up or down. You'll notice that it'll either change to an H or an S. Okay? So the H is hours, and the S stands for seconds, and the M stands for minutes. But this is how I like to remember it. The M stands for microwave. Because just like you would enter time into a microwave, when you're in M mode, it's the same thing. So 00:05M, how much time is that? It's 5 seconds, because on a microwave, if you hit in 00:05, it'd be 5 seconds. See? M, microwave. That's my hint. I know it's clever, sure. So if you guys change it to H, and I enter in 00:05H, 5 minutes. See how confusing that is? So why on earth would we put that in there? Well, if you need a 8-hour off time, you can't put in 99 minutes and 99 seconds, right? You'd need to put in 8 hours. And so that's why that variable's in there. The factory default is left at M so that it's always in minutes. So if you ever needed to change it on the rare occasion, you can. But I just wanted to be sure you guys knew how that read. So let's change it. Let's be sure that we're at 00:05M. And so our high water delay is 5 seconds, which means when that top float lifts up, the panel's going to wait 5 seconds before it goes into an audible and visual alarm. Yep. Yeah, you can hit OK. Okay. So if I've got a time dose system and I've only got 3 floats out there, and I've got an override timer, right? Or maybe I have a recirculation system, same deal, and I've got this override timer that's tied into that high water float. Well, I want to give the override timer a chance to catch the system back up. So what I can do is I can say, well, if my override timer has like a 30-minute off time, I can change my high water delay to maybe like 31 minutes, right? So it'll wait for a little bit, and if that cycle or that faster cycle doesn't clear my alarm, then it will alarm. Because if the float stays up, it's gonna kick off. So that's what the delay is for. The next, and the other thing too, is sometimes it's, every once in a while you run into like a home that may have a weird surge event that goes on. Sometimes it's like the tub, the big tub, the sauna tubs are very popular. And so sometimes that's actually a nuisance saving feature. Let's just put it that way.
So, Scott?
Yeah.
So if we were doing an alarm test by lifting up the float,
Mm-hmm.
and this was on an hour delay, and we didn't know it was on an hour delay, we'd be standing there all day going, the alarm's
Yep.
not working.
So remember that, so here's another hint, is remember that input screen I was at? Okay, whenever you're testing a float like that, if you're lifting the high water alarm and you're not hearing it go off, because the factory default's still 5 seconds, so at least stand there for 5 seconds, but you're not hearing it go off, the first thing that I'm going to tell you to do is I'm going to say, okay, lift the float up and let's check the input. I mean, that's the very first thing I'm going to do. Is the float sending a signal to this? Because then we can start to dissect the whys and the hows. Because most of the time you're going to go out there and you're going to do that, and you're going to go back to the panel and there's not going to be an input. It's, there's something's wrong with the wiring, the float's gone bad, something like that.
And why is it again you want a delay?
Because on some systems, now if you had a demand dose system, you don't want a delay.
Okay.
There's no point. Because you're not hoping that the pump will finally start out. I mean, if it's supposed to run and it's not running, but on a time dose system, what it can do is it like if somebody drains the tub, is it gives the system a little time to catch back up before it actually sounds that alarm.
Hey Scott, just so you know, we could probably count the time dose systems in Idaho on one hand,
Oh, okay.
just to let you know.
That's good to know. So you guys probably aren't going to use the delay a lot.
You guys see, no time dose, yeah, there's a few on drip systems and stuff, but
Okay.
not many.
Okay. So you're probably not going to use the feature very often.
Second question, who does the wiring in Oregon? Does it have to be a licensed electrician or do installers?
No,
wire these
it's a licensed electrician or an installer with a limited, it's a limited installation permit, or a limited installation license that they can obtain to wire from the control panel out to the floats and pump. So we're still using licensed electrician, but this is, and I'm not trying to make any waves here, but it's the sort of gentleman's code in Oregon is the majority of the installers are the guys that are coming out dealing with the wiring after the electrician. So the electrician comes in, he wires it, man, I hope it's at least kind of right, and then the installer's the guy that's back out troubleshooting it because he understands what's supposed to happen. The electrician just is trying to interpret a diagram the best they can. That's usually what we see. So nobody really hassles them over that because that's how we get them to work.
They don't like getting their hands dirty.
Yeah, there is that too. That's why they like those external boxes so much. So that's the high water delay. Now, if you'll notice when you guys hit the OK key, you had a flashing kind of block on there. And what the flashing block means when you're in this mode is that you can make changes. So if you hit OK again, you'll notice that the block goes away. And that accepts the changes. Now we can go to different screens. So if you have the block on there blinking, it means that you're making changes to that screen. If the block isn't there, it means you're just going or navigating through the screen. So we can go ahead and let's all of us press the arrow down key now that we don't have the flashing block. And what's our next parameter? Off time, okay? So if we're gonna time dose, this would be our set off time or delay time in between doses. We can hit arrow down again. This should be an on time, right? So this is the on time for the pump run cycle. Again, if we're in time dose mode, this is how long we want the pump to run when it's called to run. Let's go ahead and press arrow down again. The next parameter is off time, or I'm sorry, OVR off, and this is the override off. And what this is this is usually tied to that high water alarm like I was telling you guys, to where it's an auxiliary timer or it's a backup timer, so to speak. So if we run into that high water condition, we can get things moving faster. If we press it,
Is there's 4 floats, that would be the 4th float too, right?
that would be the third float.
Or the 3rd float?
Yeah, it's tied to terminal number 3.
Right.
And if you guys look in the panel, you'll see that there's a little red strip in between terminal 3 and 4. And what that's doing is that's actually tying the override input signal to the high water alarm. That's all. And that's important to note when we get into the demand side of things. So if you arrow down again, it should be override on, which is, again, that's the on timer for our override cycle if we're using the time dose feature. Normally it is the same as the standard on time, just because we don't want to send more volume out to whatever, whether it's a treatment system or a drain field or whatever. We just want to send it more frequently. Arrow down again, and we should be coming into our minimum override time. I'm not going to go into this if you guys don't do time dose. It's just a feature that it's a catch-up feature. What it does is it keeps it into the system in an override cycle for a set amount of time, because if we've tapped that high water float, more than likely we need to process some water. Let's arrow down again. Minimum runtime. So the minimum runtime is a feature. This is where we start getting into the demand dose side of things. If I have a panel set up and I've only got 3 floats with me, right? But I've got a demand dose. And so I have to use my bottom floats in RO. At least I should be. No purple jumper wires out in the field, guys. Not that that's ever happened. So I've got an RO float, and then I've got a high water float, right? So I've burned up 2 floats. Well, I've only got 1 left. So it's got to turn the pump on. But we talked about and we saw the low differential on this float. So we can't use it as an on and off float, right? Because it'll chatter the contactor in the pump. So what you do is you establish what's called a minimum runtime. So you wire the float into terminal 3, and we'll look at that diagram. You have to remove this terminal link. You have to. If you go to a demand dose and you see that red terminal link in there, it's got to go. because it's going to really mess things up with your relationship with the homeowner if you don't. Let's just put it that way. They're gonna hear beep beep, and then the pump's gonna turn on, and then it's gonna go away. And I'm not kidding you, you will hit a point when they will be running, literally running out their back door, trying to catch it in action because they know that thing's going off, but by the time they get there, it's over, and there's nothing happening. And you will put somebody in the nut house. You know, so something to think about. So if you have somebody that's like going crazy, check this. So you're gonna remove that terminal link, and then what you're gonna do is you're gonna tell the pump to run at least so much time when that float lifts up. That's how you get rid of the chattering. So you've got that float sitting there, and it's got this little tiny differential. The liquid level rises, and it turns it on, and it's gonna tell the pump to run. Now, if that float drops, it doesn't matter. As soon as it lifts up and sends a signal, it tells the pump, run for whatever you've set it to. And that's a pretty easy calculation if you know your pump's flow rate. If you want a 90-gallon dose and you've got a 30-gallon minute pump, what are you going to set your time to? 3 minutes, right? Okay. Now, it's never that simple in the field. It's usually like 38 gallons per minute, and you need a 75-gallon dose. So you got to get out your calculator. But that's how that works. That's how you can operate 3 floats on these guys.
Now, when I started, all the systems I saw out there were 2 floats.
Mhm.
Yeah, the bottom one was an on-off, and the top
Yep.
one was high alarm. What is the purpose of the low water redundant off?
There's,
I've seen thousands of tanks, and
sure.
it,
There's a couple things. When the on-off floats stick on, it stops the pump from just running itself out. Floats are fairly cheap, pumps aren't. So it's a safeguard. The other thing it does is that if you have a leak, it can identify it like a leak in a tank. On the recirculation systems, what happens is that because they recirculate and the timer's just always running, there's nothing stopping that. Well, if I break a pressure line on a recirculation system, it's just going to keep pumping water out, but I don't get anything back because I'm pumping out somewhere with a broken line. So the RO will catch that because you'll run the tank out of water. And so that's how you can actually pretty quickly find a broken line problem with a feature like that. So that's mainly what the purpose, that's what we're using them for.
That is
Is
the
that
kind of float that goes back, the bottom one. I mean, that seems to be I replaced, it seems like hundreds of them.
The ROs. Yeah, and it's because it's always submerged.
Right, yeah.
How many years do you get out of them?
It seems usually right around 5 plus.
5, okay. Well, that's good. That's pretty decent then.
Yeah.
Okay. So the next one, we can hit arrow down again, and of course I showed you guys how to make changes on that, but we can hit arrow down again. And this is interesting because this is kind of like the old HP calculators and the reverse Polish notation. Is we're saying time dose. Okay. Well, do you want time dose on or off? So you don't get to say, no, I want demand dose. It doesn't change. It's always going to say time dose. But you're going to say, yes, on. I want time dosing on. Or what we can do is we can go in and press OK. And if you hit the arrow up or down, you'll notice that we can switch it on and off. Do you want to turn on the time dose feature? No, I want it off. And now the panel is in demand dose. Yep. It's that simple.
I'll be calling on Tuesday.
Perfect. You guys can switch them off, that's fine. It doesn't matter to me. Regardless, because it's irrelevant to what we're going to do next. So then you press OK to accept the change, and then you hit arrow down again, and it should bring us back to our high level alarm delay. So once you're in this proverbial screen, once again it's a loop. So you can keep pressing arrow up, or you can keep pressing arrow down, it doesn't matter. That's why when you call me up with an MVP panel, every once in a while somebody will stump me, and I'll have to actually look up the reference charts and the diagrams, because I can just listen to what you're telling me as you're going through all the screens and give you suggestions on inputs. Because I know that once we get into those parameters, you can just keep pressing arrow up, and eventually you're going to come right back around to the same one over and over and over, and you can just press it forever. So to get out of it, once we've made all of our changes, go ahead and press escape twice, and you'll notice that you'll flash by that set parameters screen, and we're back to date and time. The center of the MVP universe, the date and time. So now I just want to show you guys some general, more electromechanical troubleshooting tips. That's basically, you guys have passed the MVP logo programming certification course. I'm joking, but that's basically it. That's all you're ever going to need. So one of the things I want you guys to notice, and this is just a hint, whenever we're troubleshooting over the phone with you guys, is running the pump in manual is if you flip the switch to manual. Okay, so you guys can go ahead and flip this toggle switch up here to manual. And you'll notice that that motor start relay or motor contactor, the little white tabs have drawn in, and we are more than likely or hopefully in a properly functioning system running the pump right now. Okay, manually running the pump is flipping the switch into manual. Now if we kick it back off, we can just kick it into the middle position off. This is not manually running the pump. This is making my day miserable. Because if you're pushing the relay in like this, that doesn't help me. Because what I'm trying to figure out, if your pump isn't running, is why or what is causing the pump not to run. And if the coil in this relay is burned out, and you're doing this, that doesn't tell me that the coil's burned out. And I'm going to move on to my next step. So what I'm getting at is that when you're diagnosing these things, don't ever do a manual manipulation like that. You always want to run off of panel power, so to speak. You're trying to simulate what it would be doing on its own. And so pushing in like that, and sometimes you have to be even careful using the jumper wires or wiring around stuff, because you might be wiring around the problem. So just, helpful hint. When the toggle switch is up in auto, of course we know that that means that the relay is going to operate off of, and so is the alarm. It's going to operate off of whatever the logo is saying. So auto, in the case of the MVP, means that it's waiting for a signal from the logo unit. In an electromechanical panel, what it means is that it's operating off of the float signal side. So when you're in auto mode, automatic, it's literally operating off of the float switches. That's the best way to comprehend or look at that. When you're in off does not turn off the panel. It does not turn off the logo unit, as you will notice. It doesn't turn off power going out to the floats. All off does is it restricts power going to the coil in this relay. That's it. So this switch, if this switch goes bad for some reason, and you can't seem to get power over to this contactor, I would go, this is one of the things I would check in that line. The other tip, and I'll draw this up here in a second because I'm going to run out of time, but is I'm going to show you guys how to troubleshoot a motor contactor. It's pretty simple. It comes to the switch, and then of course we've got our breakers. And the breakers, I don't know, I probably can't get one to trip out, but you've really got, no, I can't. I have to smack them. But what is deceiving is when they trip to middle. And so I've actually caught this a few times. Be sure that when I say check the breakers, actually do a physical off-on. Don't just look at it. Because if you look at it and it's tripped, sometimes, especially, not that anybody would ever do this, like the panel I was at on Monday, but if the panel's like this far off the ground, right, it's hard to look at that and say, hey, I think, oh no, the breakers are fine. And it doesn't hurt anything to cycle power real quick. So the last thing is that I've got my wiring diagram up here, and before we get into the motor contactor, I don't know where I put it in my pocket? Slide remote's around here somewhere. The wiring diagram, this is what comes with every panel, and you'll see all those numbers at the bottom, and they refer to a float diagram. Of course, this is the pump. That's the pump. So the pump wires into those terminals. But then you've got a float arrangement diagram. Oh boy, that's what I was afraid of. That's normally right side up. But you have a series of floats that ties into the terminals on each individual terminal break. And so when you're wiring up the panels or troubleshooting, it's important to know what float is supposed to wire where. And the diagrams really help with that terminal wiring. I'm going to reference you to that every opportunity I get. If you guys actually want to look at the float arrangement diagram, believe it or not, they're incorporated with the panels. And you'll notice that one on the DMs is labeled demand dose and one is labeled time dose. And depending on what you're up to, that's the one you want to refer to. And that's really important because like I said, you have to remove that terminal if you're going to do a demand dose system.
I had a quick question.
Yeah, go ahead.
Now, when you put this in manual, if the bottom float isn't up, it won't work, right?
That is correct. If you put it into manual and the RO float is not up, the pump should not run. And by the pump should not run, the motor contactor should not engage, right? All right.
Just want to make sure.
Nope, that is a great question. So the last thing I'm going to show you guys as we wrap up here is I'm just going to draw a real quick illustration of a motor contactor, and it's going to be pretty ugly, so I apologize ahead of time. But the motor contactor typically is going to look something like this. And then you've got something in the middle that activates the relay. And it's labeled A1, A2, usually this is also A2, and then you've got L1, L2, L3, is that L13, and then you've got T1, T2, T3, and T14. Motor contactor 101. There's two sides to this. The A is for activation. I don't know if that's really what it stands for, but it's how you remember it. A activates the coil inside of this guy. So the A1 and A2, and by the way, this A2 is the same. I'm just showing you guys this because it usually just makes it easier to wire. But that's a hot and a neutral, and it activates the coil. So that's all it does. It has nothing to do with the pump power. It's just to turn the relay on or off. That's it. So if I'm flipping my switch and I know my bottom float's up and I don't have an alarm, and I kick it into manual and nothing happens in auto, the first thing I'm going to do is I'm going to kick my switch into manual, and I'm going to see if I'm getting voltage at A1 and A2. See if I'm getting 120 volts. Because if I am getting 120 volts right here, between these 2 points, that thing should be sucked in. And if it's not, then I've probably got a bad motor contactor. Troubleshoot complete. And so I can replace that part and move on with my day. But if I don't have voltage here, that means that I'm going to want to investigate further down the line in the panel, and we can begin a comprehensive troubleshoot. Now, if I do this and my relay does work, there's the other side of it. It's the pump side. And the pump side of the relay is the L1, L2, L3, T1, T2, T3. And this side of the contactor is just for pump power. And so if I've got my pump circuit breaker on over here, and I'm just gonna, it's on, right? Okay. So it's on. I've got power running to L1. Then I've got a neutral terminal, and this is for 120 volt, running to L2. And that's always on. And so if I have my breakers on, I should be able to take my voltmeter and get 100, and this is a 120 volt panel. I should get 120 volts right here if I put my prong between those two. It really doesn't have to be on, off, doesn't matter. I should always have at least, 120, I mean, we know 119, 118, right here. Because that's always supplying ready power. When the relay kicks on, it actually closes contacts but on these legs, which sends power out to the pump. And so if I have it in manual and the contactor sucks in, I should also have 120 volts right there. If I have 120 volts here, the contactor's on and engaged, and I don't have 120 volts down here, then I've got a problem with my contacts, right? I can use a continuity meter with it closed and figure out which leg is bad. Now here's the hint, and I can move whatever bad leg over to L3 and T3 until I can get a new contact. Oh, it sounds like it's time for me to wrap up. I can hear the applause already. The last thing I'm going to tell you guys is that the contactors that have the L13 and the T14, those are not motor-rated contacts. In fact, if you rip one apart ever, because you've got like a bad one that you've replaced, tear it apart and take a look. They're little, tiny, weak contacts. They're not designed for motor amperage. So don't ever try to run a pump line through here. That's a bad idea. It won't last long. So that wraps it up. That's all I've got. I've got a picture of a nice, tidy installation up here, just for reference and giggles. But if you guys have any questions, I know that we're going to move on to the next activity. But you can hit me up. I'll be here. I'm with Alan and Justin, so I'll be here until tomorrow afternoon. So if anything comes up, just let me know. Otherwise, thanks for your time. Appreciate it.